Right. Remember, we are always either with data related things or process related things. So we can finish the first topic, that is data related thing, that is variables and data types. So our second topic is related to processing, because remember we are in structured programming. So structured programming means we represent our data and then process it to get the results or the information. So how do we represent our data? Using variables. And also when you represent data, you must be aware of the data types. Now, second topic is operators. So operators are way of processing, right? Way of processing. So when you represent your data into variables and apply operators, then you get the results or the information. Okay. Right. So what are the operators in Java? Actually, not only Java, almost every programming language have these operators. Maybe slightly different name, or maybe one of the operator is missing in a particular language, maybe different operator is there, right? But in general, all the languages, computer programming languages, they commonly support these operators. Okay, right. So let's categorize those operators also so that we can easily understand it. Okay. So these are the operators in Java. Of course, in all the other languages, also 99%, these are the operators, and this is the classification. Assignment operator, then arithmetic operators are there. We can subdivide them into binary arithmetic and unary arithmetic. Arithmetic assignment operator is there. Or set of arithmetic assignment operators. A concatenation operator for strings. Logic operators are there, and, or, not, and so on. Equality operator for is equal, is not equal operators. Comparison operators like is greater than, is less than. Ternary if else operator is there. Bitwise logic operators are there. Bit shift operators are there. So if you take C# or Python or PHP, there also you have these operators. Most of the operators are there. Maybe one or two missing, or maybe one or two additional things are there in a different language. Okay. Right. So what is unary? I will explain. Okay. Right. So I will explain when we get into the arithmetic. Okay. Right. So the first one is assignment operator. That is something we have already used. Right. So last week or last class also we use it. So you assign value 10 to variable A. You assign value 20 to variable B, and so on. And here you assign the value of B to variable C. That is also assignment. So therefore, assignment operator is not a new thing, but it's an operator. Assigning value to a variable or value of another variable to a different variable. Okay. Right. So that is called assignment operator. So that is nothing new. We have already used it. So the next we have binary arithmetic operators. So those are arithmetic operators. Arithmetic operators means we can apply those operators on numbers. Right? We can apply those operators on numbers. So why do we call it binary? Because these operators need two operands. So when I say 5, 3 plus 4, this is the operator. These are called operands. So binary means you need two operands. This has nothing to do with base 2. Here binary means two operands. Okay. Like addition, subtraction, multiplication, division, and mod operator. Right? Mod operator. So mod means when you divide the remainder. Iturugana. Okay. Right. So how now you know how these operators work. Okay. We can apply these operators for whole numbers or decimals, or we can even mix. So therefore, there are some tricky scenarios also. Okay. For example, if you have both whole numbers, your result is always whole number for all these operators. Okay. But if you have at least one decimal, your result is a decimal. So those are the small patterns you need to remember, understand. So if you have both whole numbers, the result is whole number. That means both in, result is int. But if you have at least one decimal or both, the results are also decimal. Okay. Right. So add will add two numbers. Subtract will subtract two numbers. Multiply will multiply two numbers. Divide, if both are whole numbers, you will get the whole number division. For example, 7 divided by 2 will be 3. But if you have a decimal value, right, so then it will go into decimal division. at least one decimal value means decimal division. Otherwise, whole number division with the remainder. But remainder you can get it using the percentage mark. So this is if you do whole number division, what is the remainder? So for 12 divided by 5 is 2, remainder 2. So therefore, this is the remainder 2. So here also remainder 13.5 divided by 5, that is 5 into 2 is 10. Then 3.5 is remaining. So that 3.5 is given because this is the remainder operator. Okay. Right. So that is, those are called binary arithmetic operators. So let's do small example also and proceed then and there. For example, say I will straight away write in S out so that I don't need to declare variable. Okay. Say something like 5 plus 4.1. Sorry, 5 plus 4.1. So because at least one value is decimal means result is decimal. So the answer will be 9.1. 9.1. Can just right click and run. Right. So the output is 9.1. But if both are integers or whole numbers, definitely output is also whole number. For example, 5 plus 4 will be 9. 9. Okay. Right. So I'm not going to take each and every example, right? But some tricky scenarios only I'm interested. Maybe something like this. Say 8 mod. Mod means percentage mark. 5. So 8 mod 5 will be 3 because when 8 is divided by 5, the remainder is 3. But then what about 8 divided by 5? Then it is the integer division. So 1, 5 and 3 remains. But the mod operation will say the remainder. Okay. But when it comes decimals, things are little bit fuzzy. For example, if I say 7.5 divided by 3. So what is the answer? Can someone guess? Of course, we will not be able to guess unless you know how to computer process it. So this will divide 7.5 by 3 normal way. So that means 0. Initially 2 point. Then for 15, it is 5. So the answer is 2.5. Okay. But this is the remainder. So but remainder we'll consider that this is the integer division and give you the remainder. So therefore, when 7.5 divided by 3, how many 3s are there? 2, 6. Then 1.5 remains. So that 1.5 is given. So this is a little bit tricky way. So therefore, examiners like to give questions like this. Okay. So here it does the normal division, but here it does the not the integer division, but it doesn't go into decimal source. How many 3s are for 7.5? 2, then 6, and remainder is 1.5. So that is how it works. Okay. Right. Especially the division and mod is somewhat tricky, but other things are very easy. If both are integer, if at least one is decimal. Okay. Right. So those are the binary arithmetic operators. So then we have unary arithmetic operators. So we have 4 unary arithmetic operators: plus operator, minus operator, increment operator, and decrement operator. So plus operator, usually we don't use because it's implicit. But increment and decrement and also minus operator we need to use. Okay, so let's take an example. Right, so let's say I have a variable int a equal 12. So if I want, I can say int b equal maybe minus a. So that is minus operator. So therefore b will be minus 12. Okay. S out b So that will be minus 12. We can run it. It is minus 12. Okay. Right. So then we have the increment operator. So for example, if I say B plus plus or plus plus B and S out. So when you increment operator will add 1. So when you add 1 to minus 12, what is the value? Minus 11. Therefore, this will be, when you print it, minus 11. That is, we are adding 1. Okay, if it is a positive number, say 10 will become 11. And this is minus 12 become minus 11 because minus 11, minus 12 plus 1 is minus 11. So if you have any questions, you need to tell. Okay, right. So that is increment operator. Similarly, you have the decrement operator that will reduce the number by 1. Okay, and there's a tricky scenario. So examiners are really interested about tricky scenarios. Okay, what is that tricky scenario? Usually, it doesn't matter whether you write like this or write like this. Both are the same. Add 1 to the current variable. Right? Add 1 to current variable. So now it is 1. Then minus minus means 0. Now again you increment by 1. It is 1. Now again you increment by 1. It is 2 now. Okay. But there's tricky scenario when you use with equal mark. Right? Equal mark. Okay. So let me explain that because examiners are really interested about those tricky scenarios. Let's assume I have variable. Say int x equal 10. Okay, let's say x equal 5. Now I want to do something like this. Int y equal plus plus x. Now I want to print x and y. Say x and y. What is the output? X is 5. Now you increment x by 1, then x is 11, 6. And this 6 is assigned to y. So therefore, x is now 6. And y is also 6 because after incrementing, we assign the value to y. So the output will be 6 and 6. I hope that is something you can understand. Okay. Right. I will call this x1, y1, x1, and I print x1 and y1. Obviously, the output is the same. Just I rename the variables. But what happens if you write like this? This is a tricky scenario. Examiners are interested in tricky scenarios. Okay, so let's call this x2, y2, x2, x2, y2. Right, of course, this also give me the output 6, 6 because I just renamed the variables. Okay, right, but what happens if I do like this? Rather than plus plus x2, I will say x2 plus plus. Now the output will be different. Usually, it doesn't matter whether it's plus plus x or x plus plus, but when you use together with assignment, it matters. Right? So here it means first you increment it by 1, then assign to y. So that is why both are 6. Here it means first assign the current value to y and then increment the x. So therefore, your y will be 5 because current value is assigned to y, then only x is incremented. So that is, therefore now only x is 6. So therefore x2 will be 6, but still y2 will be 5. So that is a tricky scenario that you must understand. And okay. Right. So this is a tricky scenario because in the second example, your current x value is assigned to y, therefore y is still 5, and then anyway x is incremented. Okay. That is something you need to understand. So what will happen when you give wrong output? So how do you give output? Because output is the result, right? So I don't know what you mean. So usually we give input, right? You can't give output. So I'm not very sure about what you're asking. Right. So that is how plus plus operator tricky scenario operate. Okay. So usually it doesn't matter whether it's plus plus x or x plus plus, but when you use together with assignment, it has a bit of effect. Okay, bit of effect. Because here first we increment and then assign. Here current value is assigned and then increment. Okay. Right. So now we move on to arithmetic assignment operators. So those are just shorthand operators, just to make your life a little bit easier. So when you say, okay, let's straight away do an example. Right. So you mean this example? Which one you want me to explain? Right. So usually it doesn't matter whether it's x plus plus. So I will explain using the code here. Right. So usually it doesn't matter whether it's I plus plus or plus plus I. Okay. Whether it's I plus plus or plus plus I. But if you use it together with assignment, it matters. For example, you can say I is 10, J is 10. Right? I is 10, J is 10. Now this assignment says K equal I plus plus. So here what happens is, first the current I is assigned to K. Current I is 10. So therefore K is 10. And then I is incremented. Okay. Sorry, K. So K is 10. And then I is incremented. So therefore I will be 11. In this case, first J is incremented. This is called prefix notation. J is incremented. J is currently 10. So when J is incremented, J is 11. And that new J is assigned to K. So therefore J is also 11. L is also 11. So therefore output is 11, 11, 10, 11. Here current value is assigned and then incremented. Here current value is incremented and then assigned. Okay, so that is how that is a tricky scenario that you must experience by coding and see. Right. So now let's move to arithmetic assignment operators. So you usually the arithmetic assignment operators are sort of additional thing. It's not a must. Some developers use it. Some developers they don't use it much. For example, now remember this is programming. So the one of the confusion if you are absolutely new to programming is say I have variable, say int. So let's say int C is 10. Right? So in programming, we can write something like this. C equals C plus, say C plus 5 or something. So this is perfectly okay because this is not equation. Right? So don't think that this is the equation. Right? Some students think that this is the equation. No, this is programming. This is not maths. For example, when someone say x equal x plus 5, someone will say then x to x get cancelled. No, yes, that x to x get cancelled. That if it is mathematics, algebra. But this is not programming, this is a statement. So this means to current C value of what the current C value is 10, add 5 and assign it as the new C value. If there's a memory address we refer to as C, they are earlier 10. After this line is executed, that memory address has 15. So the new C value is 15. So that is what is mean by that. Okay. So in programming, we can write like this because this is not a formula or this is not an equation. So if I print it, C will be 15. New C will be 15. Now this can be written little bit shorthand way. Of course, this is perfectly okay. If you want, you can write it like C plus C equal 5. So that means that is same as C equals C plus 5. Okay. Or whatever, C equals C plus 2, C equals C plus 10. Or you can write minus equal, multiply equal, divide equal, mod equal. Right? Again, the output will be what? 15. So this line is same as this line. Okay. 15. And also we can extend it to any other operator, any other arithmetic operator. For example, I can say new C multiply equal, say, to 10. Then what is the output? Can anyone tell me what is the output? So I print C now. But by this, at the end of this line, C is 15. So this means C equals C into 10. So this is same as C equal C into 10. So currently C is 15. When C multiplied by 10 and assigned to C, new C is 150. So this output is going to be 150. Okay. Right. So those are called arithmetic assignment. You do arithmetic and assign to the same variable. So this must be a value. Okay, this must be a value. Okay. Right. So now it's 150. What about this? C minus equals C. What is the output? Anyone? So that is what is my education. You think about some tricky scenarios. So education is an internal job. You think. Right? So a lot of people think that education is attending classes. No. Education is something you do alone. You do alone. So here we are doing bit of guidelines. So education start when you are alone with your notes, and then you start thinking about what you learn. Or you can, even before the class, you can do your education. Take your notes, take your past papers. So that is called self-study. So self-study is the best form of education. But self-study alone is not going to work, especially in professional education, because you need bit of guidance, right? Bit of guidance. Otherwise, it will be very ineffective or less productive. So when you get the guidance, you can do it faster, but only get the guidance. So spoon feeding, don't expect. Okay. Right. So now what is the output? 0. Sure. So this is same as C equal C minus C. Right. So C is 150. 150 minus 150. First of all, it must be C, right? Answer is, because this is equal to C equals C minus C. So when C subtracted C, obvious result is 0. Right. So those are called what? Arithmetic assignment operators. Now we move to another set of operators. Comparison operators. So comparison operators you can use with numbers, whole number or decimal, and also it works for char. When we use with char, it use ASCII table. You know that B is having a bigger ASCII value than A and so on. But you can't use it for anything else. You can't use comparison for Boolean. You can't use comparison for even string. Only for whole number type and decimal type, and special cases you can apply this for char, then ASCII value is used. Okay. Right. So the examples are given anyway. For example, I can say I will straight away use S out. Okay. Make it fast. If I ask whether 8 greater than 9, so this means is 8 greater than 9? Okay, is 8 greater than 9? Why can't I use that? Okay, let's do it using a variable. Say Boolean, say D is 8 greater than, so let's say 10. Okay. So why can't I write like that? Maybe we need this. Still no. Why can't I use that? It's always false. Okay. Okay. So it says that this is not necessary because 8 greater than 10 is always true. Okay. So therefore, let's do something like this. Because my IntelliJ says this is crazy because you know that it is not greater than 10. So therefore, I just pull the compiler because my Java is getting little bit too smart. Okay. So therefore, I make it two variables. Say D equal 8. I can declare multiple variables in same line. We discussed that when we do variables and data types. Say E equal 10. Okay, now I can ask is, of course, now I will call it F. Is D greater than E? Now it will not be smart. Okay. Again, it says D is greater. Okay, what is that? Anyway, I think we can compile it and run it without issue. Maybe that is a message coming from IntelliJ. You can see. Actually, this is not a message coming from compiler. This is message coming from IntelliJ. Sometimes IntelliJ try to be smart. Right? So IntelliJ try to show me that it's a smart guy. So therefore, it's giving me some suggestions. Yes, I know that D is greater than E, but I just want to test this operator. Okay, so that is why here you can see Java is not doing that. This is actually message coming from IntelliJ, not from Java compiler. Okay, so therefore I just let it compile it and run it. So therefore, is 8 greater than 10? No. So therefore output is false. Okay, output is false. Right. So therefore, likewise, you can, of course, it work for char also. Okay, char also. Let's have it out. If I ask is A single quotes greater than B, of course A is not greater than B. Why? In ASCII table, A is before B. If A is 120, B is 121. So therefore this must be false. Again, my IntelliJ says, okay, you are doing crazy thing, but anyway, I will ask it to. So my Java will not say like that. Java will compile and run. It says false because A is not greater than B, rather A is less than B in ASCII table. So this is obviously false also. Right. So those are called comparison operators. It works for numbers and characters. Okay, numbers and characters. Right. So those are comparison operators. So then we have equality operators. Now, if you have any doubt, you can just code and see. You can just code and see what happens if for this scenario, what happens that scenario. So you can just code and see yourself. And when you after coding, if you don't find the logic, so then you ask. So yes, when I do like this, I got this answer, but according to my logical thinking, it looks like I expected something else. Okay, so first you check it by yourself, right? So then see whether that is logical. And if you feel like it is not logical and it is contradicting your thinking, then you can ask. So we can discuss it, why your thinking is not practically the result. Okay. IntelliJ find the symmetrical errors. Yes, IntelliJ find all the compiled errors, plus IntelliJ try to find some additional errors also. That is why I told you that IntelliJ is too smart. Okay. So that is not something I expect because our task is not learning IntelliJ. Our task is learning Java. So therefore, don't get fooled by some of these messages. Some of these messages are not coming from actually Java compiler. Rather, IntelliJ gives us some additional uh, suggestions and so on. So those are basically warnings, not errors. Okay. Right. So then we have another two operators, equality operator. So the better way of remembering these operators is equal, isn't equal question. So the result is Boolean value. Again, this work for compatible data types. Otherwise, it will try to implicitly cast it to a compatible type. Otherwise, you will get an error saying that you can't compare. Right? You can't check whether those two are the same. So, for example, Java cannot check whether apple is equal to grape because those are two different. But if you give two grapes, it will say whether it's the same grape or two different grapes. But Java will not say check whether this particular apple is same as that particular orange. Then it will say those are not compatible to check. Okay. Not only Java, most of the programming languages. For example, let's say something like this. I can ask, is 5 equal to 7? An obvious answer is what? False. Okay, false. Let's run it and see. Earlier we had 2 false. Now we must get in 3 false. 3 false. So then what about this? Is 5 not equal to 7? Now it will say true. Because yes, they are not equal. They are not equal. So this is equal, this is isn't equal. Isn't equal, answer is true. Okay. Likewise, so just experience with those different values and see how those are behaving. Right. So I have given you some more examples. Right. So now we move on to Boolean logic operators. Does that fifth generation AI languages can find logic? Logic is something that any programming language relies on, right? So what do you mean by finding logic? I don't know what you mean by finding logic because your computer has logic gates. So therefore, obviously your computer is a logical device. Maybe your question is, can it find logical patterns? Maybe, okay. Semantical errors. Semantical errors, not all semantical errors. Maybe some semantical errors, not all semantical errors, right? AI tools can find out some semantical errors because those are intelligent, right? Not all. But of course, your AI tool must have enough information about your program, the objectives of your program, the requirements, and so on. Then only it can find it. But not 100%, some of the semantical errors. Things are getting better and better. Okay, get better and better. And our life is getting much more convenient as well as software engineers. So the good news is the tools are taking more and more boring tasks so that we can do more and more interesting tasks. Okay. So therefore, we can be more and more smart when more and more AI is used. So that is good. And the ultimate of the fun is your tools try to outsmart you. Right? So sometimes your tool will try to outsmart you. So that is where the real fun is. Okay, real fun is. Right. So what are the logic operators? So the logic operators are AND operator, O operator, XO operator, and NOT operator. AND, O, XO, NOT. Okay. And those operators obviously operate on Boolean values, true, false values. And the result is also true, false. And there are two versions of AND operators called short circuit and non-short circuit AND. Two versions of O operators called normal short circuit O and non-short circuit O. But for XO and NOT, you have only one version, that is non-short circuit version or the normal version. Right. So I don't explain you what is the short circuit and non-short circuit because I have given you an example for that. Right. And explanation also. I don't explain it again because you can read it and understand. Okay, but I will just give you an example on how the Boolean logic operators work. Right. So let's say I have a variable, Boolean variable. Let's call this G equal false. And let's have another variable, H equal true. Now if I will straight away write it in S out. G and H. Obviously, true and false. False and true is false. So therefore, output will be false. False. Don't worry, this message is coming from IntelliJ, not from Java compiler. So therefore, now after true, I should get false again. Again false. Because true and false is false. But if I say XO, true, false XO true is true. Right? So if I use XO, this is the symbol we use for XO. So not this. But this. Now it will say true. Because true, false XO true is true. Now it should be true again. So the final output must be now true again. Okay, why is that? Sorry, GH. System, typing mistake, system. Fine. And now it is true. Because false XO true is true. Right? AND operator, XO operator, likewise you have the operator, pipe character. Right? 2 pipe characters. And not is the exclamation mark. Okay. Exclamation mark. Right. I don't take all the examples. I just remember my task is I remember this is super important. Okay. So this is super important. Okay. So this is the most important sentence I talk today. That is, now this is higher education. This is not you are in grade 1, grade 2, Montessori, Shishatha class. Right? You are following a degree. Okay. You are following a degree. So therefore, my task is help you, guide you. Guide. I think guide is also not a good word for higher education. University වල ඉන්න student guide කරන්න ඕනේ නැහැ. Guide කරන්න ඕනේ මේ පොඩි උන්. Right. My task is help you. Right. Help කියන වචනේ මම දන්නේ හොඳද කියලා. අපි ඔය ටෙක්නිකලි කියන පාචන තමයි facilitate. පහසුකම් සලසනවා. මොකද help කරන්න ඕනේ මේ ආබාධයක් තියෙන කෙනෙක්ට, දුප්පතෙක්ට, ප්‍රශ්න තියෙන අයට නේද help එකක් ඕනේ. මොකද අපි කාටවත් help කරන්නේ. So I think the better word is my task is facilitate you. Facilitate you. පහසුකම් සැපීමක් කරන්න. ඔයාට ඉගෙන ගන්න අවස්ථාවක් දෙන්න. My task is not teaching. So that is why in universities there are no teachers. University වල higher education වල ගුරුවරු නැහැ. Teachers නැහැ. Lecturers ලා ඉන්නේ. Because we are not supposed to teach you. Right? We are supposed to help you, guide you, facilitate you. Okay. So your task is get that facilitation, bit of help, guide, and your task is learn. Learning is your task. Learning is your task. You put up effort, you do certain things and do it. So attending a session is not really learning. So attending a session is, or attending a lecture is, you get that guidance. So then after the session only, you start your studies, your learning. So that is something you do. Because when you learn something, that will remain with you. Okay. So therefore, just remember, just attending a session is not enough. That is why we try to make these sessions as short as possible. Short as possible. Because with minimum help, guide, you must be able to learn it. You must be able to learn it by your own. Okay. So therefore, don't expect me to do all the things. If I'm doing a lot of things in the class, that means I'm not a good lecturer. Right? Maybe I'm looking for your money. අර කියන්නේ ඔයගලන්ට බටර් ගාලා ඔයගලන්ට තියා ගන්න හදනවා. එහෙම ක්ලාසස් තියෙන ඕන තරම් හරි. ඔයගලන්ට බටර් ගාලා කොහොම හරි පන්තියේ තියා ගන්න හදනවා. නමුත් ඒකෙන් ඔයගලගේ ජීවිතේට කරන හානිය අතිවිශාලයි. හරි? අතිවිශාලයි. මොකද මේක එහෙම කරාට කමන්නේ එකේ පන්තිය දෙකේ පන්තිය. අර ළමයි හැමතිස්සෙම ඉල්ලන්නේ ටීචර් කෝ කියන තමයි ටීචර් හන්ද තමයි ඉස්කෝලේ යන්නේ. අද ටීචර් ආවේ නැහැ කියලා ළමයි අඬනවා. But this is not like that. So we want make you independent as quickly as possible, as fast as possible. Right? So we want to make sure that you need less and less guidance, less and less help, and you become more and more independent. Okay, so just keep it in mind. Right? But of course, different students may need different levels of help, but try to make sure you don't rely on any other's help, not even our help. After sometimes you get into your self-study mode as much as possible. Get the help, get the guidance, not teach from your lecturers. Sorry, not learn from your lecturers. So we are not supposed to teach you. Okay, just remember it. Okay, right. So therefore, we try to make it less and less. Okay, because that is what is expected. That is the purpose of education. Make you more and more independent. Okay, right. So therefore, what is the difference between this and then this, and you must learn it by yourself. What is the difference between this so and this so? In what kind of scenario the use of this and this matters? Or in what kind of scenario it doesn't matter whether you use this one or this one. So that is something you must learn. You must learn it by yourself. Of course, the note is there. Okay. Or you can use ChatGPT, do a Google search, and learn it. Okay. For example, I will just show you what would be the answer from ChatGPT. Just because otherwise you don't use these features. Right? In Java, what is the difference between, okay, not this and single and. Okay, or I can say explain using code, or let's say both are logical operators. So you can say this one is a short circuited operator. Okay, then we have short circuited. Then I explain that. One example is example example okay, non short circuited version. Okay, then බලන්න මොකද්ද මේක තේරුම් ගන්න. ඒත් ඔය chat GPT ඉගෙනගෙන යනවා. අනිත් පැත්තට උපදෙස් දෙන්නේ නැහැ. ඒක උගලන් ඉගෙන ගන්න බැරි වෙනවා. හරි. So ඉතින් එයා කියන එක තේරෙන්න නම් තව කෙනෙක්ගෙන් අහන්න. නැත්නම් යාළුවෙක්ගෙන් අහන්න. නැත්නම් ක්ලාස් එකේ ඊළඟ දවස් මගෙන් අහන්න. හරි. එහෙම අහන්න ඕන. හැබැයි අහන්න දැන් ඔයාලට ගොඩක් කට්ටිය ඉන්නවා. විශේෂයෙන් chat GPT ඉන්නවා. මම සාමාන්‍යයෙන් දවසකට chat GPT එකෙන් අහන ඇති ප්‍රශ්න 10ක් විතර. මම ඕන හරි. මම දැන් අද මොකක් හරි ඇහුවද කියලා අදත් අහපුවා ඇති. මම දැන් Google search කරන එක ටික ටික අඩු වෙනවා. දැන් Google search කරන එක අඩු වෙනවා. chat GPT පාවිච්චි වැඩි වෙනවා. හරි. එහෙම තමයි. මොකද Google intelligent නෑ. chat GPT intelligent. දැන් Google දන්නවා වැඩේ දැන් නාලා තියෙන්නේ කියලා. ඒකන්ද Google මොකද කරන්නේ? Google දැන් email search result දෙන්න මොකද කරන්නේ? AI result දෙන්න පටන් ගන්නවා. right? So what is the difference between and in Java? බලන්න දැන් සමහරට Google උත් කරන්නේ AI වලින් උත්තර දෙන්න පටන් ගන්නවා. මොකද එයා දන්නවා නැත්තම් මම නෝන්ඩි වෙනවා. හරි. එයාට AI උත්තරයක් නැහැ මේකට. තේරෙනවද? එයාට AI උත්තරයක් නැහැ. එයා දුන්නේ search result එකක් විතරයි. search result එකක් විතරයි. But sometimes it gives you the AI results now. Okay? Because it knows that sometimes AI result is better than Google search. Right. So that is logic operators. Logic operators. Or Boolean logic operators. Right. So you must understand the difference between short circuit and non-short circuit. Okay. Right. So now we are into the final set of operators. Binary operators. So bitwise operators. So why do we call it bitwise? Because these operators operate in bit level, 1-0 level. So again, we have the bitwise AND operator, bitwise O operator, bitwise XO operator, and bitwise NOT operator. So the same thing, remember AND means when both are 1 only 1, otherwise 0. O means when at least 1 is 1, otherwise 0. XO means when those are different 1, when they are the same 0. NOT means 1 becomes 0, 0 becomes 1. Only thing is now it happens at bit level. So these bitwise operators are there in all languages. Okay. So let's take an example. I'll copy paste this because otherwise it take time for me to, okay. This won't take much time, right? Right. So let's say I have a variable, say byte variable, EFGHI, say 14, and J, let's say 8 or 9. Right now I want to do bitwise AND operator. Okay, bitwise AND operator, and straight away I print that I bitwise AND J. Now what is the output? So this is how it happens. So what is 14 in binary? Because this happens in bit level. And this happens because these are numbers. Of course, if it is a logic, true, false. If it is a numbers or char, it happens at bit level. Okay, so 14, 7, 0, 3, 1, 1, 1, 0, 1. That is 1, 1, 1, 0. 2, 4, 8. 2, 4, 8. 8 plus 4, 12. Yes, 13. Correct. Correct. And yeah. Okay, so 13 is what? We don't have the undo, unfortunately. We have only the redo. Okay, we have undo but no redo. Okay, so let's do it again. I forget. 7, 0, 3, 1, 1, 1, 0, 1. 1, 1, 1, 0. So then what about 9? 4, 1, 2, 0, 1, 0, 0, 1. 1, 0, 0, 1. Okay. And it is byte means 8-bit. So these are all zeros. Now we want to do bitwise AND. Bitwise AND means these bits are AND operated one by one. 0 and 1, 1. Sorry, 0. 1 and 0, 0. 1 and 0, 0. 1 and 1, 1. Of course, 0 and 0, those are all zeros. And what is this number? 1, 2, 4, 8. So their output is 8. Output is 8. So that is, it happens at bit level. But the result is again given as a this type of data. Okay, this type of data. So the output will be 8. 8. And similarly, you can try out O and XO. That of course you can do. And even not. This is bitwise O, and this is bitwise XO. Okay. So what will happen if you do bitwise O? 1, 1, 1, 1. 1, 2, 4, 8, 16, that is 15. So this will be 15. What about bitwise XO? 0, 1, 1, because those are different. 1, 0, 1, 1, 0, 1, 1, 1, 0. Of course, these are 0. That is 1, 2, 4, 8. That is 7. That is 7. 8, 15, 7. 8, 15, 7. And the examiner expect that you have done these kind of things and understood. So what about this? Not I. Not I. But the output area. Sorry, not එකේ මෙතන පාවිච්චි කරන්නේ x ඔය මේක නෙමෙයි මෙන්න මෙයා title එක. So for not we use different symbol when it comes to bitwise operators. Right? Bitwise. For Boolean, exclamation. For bitwise, different title character. Okay. Can you explain what is the output and why? I'm මෙතනට එන්නේ ඍණ සංඛ්‍යාව. minus 15. Why? Can anyone tell me why? Remember 14 is 7031 1101 1110 0000 because it's a byte. Now when you say not, what happens? All are one. Sorry, 0 become 1 becomes 0. And what is this number? Remember, computer use two's complement notation. Now two's complement notation එක පාවිච්චි කරනවා second හදා ගන්න පුළුවන්. So in two, this is two's complement. So when this is 1, definitely this is a negative number. Yes. And let's see. This is 1, 2, 4, 8, 16, 32, 64. This is minus 128. Remember? This minus 128. එක batch එකකට තාම two's complement කරලා නැහැ. ඒගොල්ලොට two's complement කරාම තේරෙයි. හරි? So therefore what is this number? Minus 128 and this is 32 this is 64. These are positive numbers. 64 plus 32 plus 16 plus 1 10 12 13 9 10 11 113 113 minus 128. What is the difference? Of course, the bigger value is negative. Therefore, answer is negative 12. Sorry, not 13. 13. Sorry, 113 and 10 is 123. 123 and 128, we have 5. 15. So the answer is minus 15 because this difference is minus 15. So that confirms that a computer is two's complement. Two's complement and then three negative zero. Right. So the computer is two's complement. So I question exam ke halat thi na hari. Exam ke halat thi. So the answer is minus 15. Okay. So the idea, the objective of these sessions is give you better understanding, confidence. Because some student ask, why don't we just do Java programming? I want to be a software engineer. Can't I do a software engineering degree? Yes, of course you can do. Right? But it's better you know what is happening inside the computer. So for example, you can be a psychologist. Right? You can be a cardiologist. වෙන කවුරු හරි දොස්තර කෙනෙක් වෙන්න පුළුවන්. නමුත් ඔක්කොම පළවෙනි අවුරුදු පහේ උගන්වන හැමදේම එකට. මොකද ඔයා ගිහිල්ලා මනෝවෛද්‍යවරයෙක් වුණාට කමක් නැහැ. නමුත් එතකොට කියන්නේ මනෝවෛද්‍යවරයෙක් වෙනකොට මේ ආමාශය ගෙන් ගන්නන්නේ කියලා. ඒක එහෙම තමයි. කොන්ෆිඩන්ස් එක බිල් කරන්න ඕනේ ඉස්සෙල්ලා. මනස තියෙන තැඟ ශරීරයක් ඇතුලේ. So therefore better to learn all the things all round and then be expert in one area or few areas. So therefore, that is why you have the computer system. Maybe you are interested in programming, but then only you know that after applying this operator, why is it minus 15? Because computer represent data in whole numbers in two's complement. And that particular bit pattern is actually minus 15. Okay. So finally, we have the bit shift operators. So what are the bit shift operators? Left shift, sign right shift, unsign right shift. Left shift, sign right shift, unsign right shift. Again, it happens at bit level. Right? It happens at bit level. Okay. So let's take an example. මට වෙලා යන හන්ද මන් ටිකක් ඉක්මනට copy paste කරනවා නැත්නම් වෙලා යන code එක ලියන්න. Of course, these are the comments. These are the comments, okay, just to give you the feeling of what you are doing. Right, so this is byte variable. Okay, I will call this ijk. Okay, or let's call this L. And now we will print L. Right, so this one, so 13. අපි ඔක්කොම මේවා ටික ඕනේ නැහැ අපිට 8ක් තියුණාත් ඇති. Okay, 0, 0. Right, so this is 13 in bit when you convert it to binary. 1, 2, 4, 8, 8 plus 4, 12, 12 plus 1, 13. Now what we do is at bit level, we shift this by 2 positions to the left. දකුණ ඉඳලා වමට තල්ලු කරන්න. පේනවද? වමේ දකුණ ඉඳලා වමට තල්ලු කරන්න. So we shift by 2 positions. So when you push this by 2 positions, these 2 zeros will be lost. So therefore 0, 0, 1, 1, 0, 1. And we fill with zeros. So we push it and those are lost. And we have sort of a vacuum. So there we always put zeros. So therefore these 2 zeros are not there. Additionally 2 zeros are added. So the result is this bit pattern. So this bit pattern is 1, 2, 4, 8, 16, 32. So 32 plus 16 plus 4 is 52. So therefore the output is going to be 52. Okay, output is going to be 52. I have not declared L. Okay, let's declare L also as a byte, but not assign a value. It's 52. Why is it 52? Because we did left shift by 2. Make a 3 now. Make මේ බිඳු තුනම යනවා මෙහෙට තව බිඳු තුනක් එනවා. Right? So you must do it and understand. Okay, so that is how you do the left shift. So try to do it for the byte, because then you can figure out the answers easily, because 8 byte is easy to work with, just 8 bits. Okay, right. So next we have the right shift, but there are 2 right shift operators, just 1 left shift but 2 right shift. What are those? Sign right shift, unsigned right shift. So sign right, easier one to understand is unsigned right shift. Unsigned right shift will always add zeros to the left side, and there will be bits lost from the right side. For example, say this is minus 32. Okay, so let's say this is plus 13, plus 13. And when you do right shift by 2 locations, these two values are lost. So therefore 1, 1 comes here. And we always add zeros. So therefore it will be 3. Output will be 3. So that is unsigned. Unsigned means signed is not preserved. If it is a negative number, still you add zeros here. Still you add zeros here. So therefore, there's a possibility that when you do an unsigned right shift to the negative number, it becomes a positive number, big positive number. Because when this becomes 0, all of a sudden number is positive. But for positive numbers, whether it's unsigned right shift or signed right shift, it is the same. But if you want to preserve the sign, then you need to do sign right shift. For that you need, then of course, if it is a positive number, here we fill with zeros. If it is a negative number, still we push it, but we fill with ones. Because when we fill with ones, we preserve the sign. We preserve the sign. So therefore, sign right shift will always give positive numbers with positive results, negative numbers with negative results. But when you do unsigned right shift, whether it's positive or negative, the result is always positive. Because in unsigned right shift, we always fill the right side or the left side with zeros. So here we get only positive values. Okay, positive values, because even the negative values become positive. But in signed right shift, positive values will remain positive, negative values will remain negative. Because for positive values, we fill zeros, negative values, we fill ones. Okay. But anyway, don't memorize these things. These are very rarely checked in the exams. But this is for, so this is another thing, right? දැන් මම මේ කියන හැමදේම සමහරව කටපාඩම් කරන්න බලාගෙන ඉන්නවා. හරි. මොකද ඒගොල්ලන්ගේ ජීවිතේ එක්සෑම් විභාග කිරිල්ල. මම මේ කියන සමහර දේවල් කියන්නේ එක්සෑම් එකට නෙමෙයි. ඔයාගේ කොන්ෆිඩන්ස් එක බිල්ඩ් කරන්න. හරි. ඔයාට මේවා එකපාරක් කරේ ඇහිලා තියෙන්න ඕන හන්ද. ඉතින් මම මේ කියන හැම එකම කටපාඩම් කරන්න ගන්නවා කියන එක මගේ ප්‍රශ්නයක් නෙමෙයි, මේක ඔයාගේ ප්‍රශ්නයක්. මම කියලා නෑ මම මේ කියන හැම එකම මම මේ සමහර ඒවා කියන්නේ එක්සෑම් එක ටාගට් කරලා නෙමෙයි. මොකද exam එක తాවකාලිකයි. ඔයයි confidence එක සදාකාලිකයි. ජීවිතේට වැදගත්. ජොබ් එකකට යද්දි ඉන්ටර්විව් එකට යද්දි පිටරටක යද්දි එතකොට අරන් යන්නේ exam results නෙමෙයි. එතකොට අරන් යන්නේ ආගේ confidence එක, පෞරුෂය. ඉතින් ඒකන්ත මම මේ කියනවා කටපාඩම් කරන්න එපා. හරි මේවා පොඩ්ඩක් දැනගෙන හිටියම හොඳද කියන්නේ. අනිත් එක මේ exam එකට ගිහලා CNC ගන්න ඕන කියන එකක් නෑ. අපි කියන්නේ නැට්ට විකාගෙන පාඩම් කරන්න එපා. CNC එක මොන කියලා. confidence එක build කරගත්තා නැති. Of course, if you can get a good A plus A, that is okay. But don't work really hard for that. කියන්නේ ඒක ජීවිතේ කරගන්න එපා කියලා මම කියන්නේ. A plus එකක් ගන්න එක ජීවිතේ කරගන්න එපා. ඊට වැඩිය ජීවිතේ කරගන්න හොඳට confidence එක build කරගන්න එක. ඔයාගේ A plus එකක් අරන් ගියත් සමහර ඉන්ටර්විව් එක ඇතුළත ගියාට පස්සේ ඔයා හරියට බයයි. මොකද විභාග විතරයි ටාගට් කරලා තියෙන්නේ. Right. So then we have the ternary conditional operator, which I will explain after doing the control structures. So the if else එක කරාට පස්සේ ඔයාලට මෙතනට ආවට පස්සේ ඒක තේරෙයි. හරි. Right. So these are some more examples with operator precedence. And operator precedence means some operators has higher priority than some other. For example, you know that in arithmetic, multiplication and division has higher priority than add and subtract. And always the brackets have the highest priority. Brackets can override the priority. In Java operators, the next you have the unary plus and subtract, unary addition and unary subtraction, then multiplication, then add, then shift, then relational, then equality, then when logic also and has highest priority. Okay, so then the O and XO. And these arithmetic assignments have the lowest priority. Arithmetic and assignment එක අන්තිමටම වෙන්නේ. ඒක කටපාඩම් කරන්න බෑ මේ ලිස්ට් එක. Just get a feeling of it. දල වශයෙන් ඔයාලට මතක තියෙන and එකට priority එක වැඩි O එකට වඩා. Multiplication, division has higher priority than add and subtract. Brackets have the highest priority. The lowest priority is with assignment and arithmetic assignments and shift operators. Sorry, not shift operators, arithmetic shift operators, assignment shift operators. සාමාන්‍ය උඩ තියෙන්නේ මොනවද මැද තියෙන්නේ මොනවද කියලා අයිඩියා එකක් තියෙන්න ඕනේ. විශේෂයෙන්ම එක්සෑම් එකේ ඔයාලට ඒ එකට එම යනවා. That's it. So we are done with operators. If you have any questions, you can ask. So after the break, we'll move on to control structures. Okay, so is that the next topic?